Hi, I'm Rosie from Bear, and we are one of the sponsors of Hands Free Hectare. And this year we're supporting the team with some remote disease technology, specifically with a Septoria spore trapper. So Septoria is the #1 wheat disease in the UK. It has the potential to cause a yield loss of about 20% if left untreated, and this can equate to about £250 per hectare, which is a serious economic loss to the farmer. Septoria is a very widespread disease. A national survey managed by Crop Monitor last year found that 82% of all crops, despite being treated, had Septoria in them at the end of the season. First of all, you've got rain and windy weather, the optimum conditions which allow the spores to be released. Once the spores are released, they then land onto the healthy leaf and start to grow within the leaf. This period is called the latent period whilst it's growing inside the leaf. And in Septoria has a particularly long latent period of 2 to 4 weeks. And during this whole period, those 2 to 4 weeks, it's not possible to see the disease with the naked eye. And therefore we're never quite sure exactly that moment when the spores land on the leaf and where the disease is present. So after the latent period, there's an interaction between the fungus and the cells within the leaf, which causes cell death. And this creates a brown lesion on the leaf, which has small black fungicide bodies in it called pycnidia. And what this means is there's a reduction in the green leaf area, which means that less photosynthesis is able to take place, and therefore there's a reduction in yield. Timing of fungicides is really important with Septoria control because the majority of fungicides work in a protectant manner, so they best perform before the spore has landed on the leaf to protect the leaf from those spores. There's also in some cases they can work in a slight curative manner once the fungus is in that latent period, but only actually the early phase of that latent period. So by the time we can actually see the disease, we won't be able to get good control. And so we're always trying to manage the disease based on how much we're predicting the disease is in the leaf. At the moment, we have to base our decisions around Septoria and therefore fungicide programs on things that we already know, but often it's in a very predictive manner. So for example, we know the variety, we know the drilling date, and we know the weather conditions, all which contribute to increasing Septoria pressure, but we're never totally confident at the exact time when Septoria comes into the crop. Spore trap is effectively a box within a field that draws in air at regular intervals. We're then able to analyse the sample that it's collected by first of all splitting the cells and releasing the DNA. The DNA is then amplified and analysed, and we're able to tell A, if the disease or the pathogen is present, and B, how much of that pathogen is present. This is then wirelessly transferred to a server which is overlaid with a weather prediction model, and that model combined with the knowledge whether the spore is present means that we're able to know A, that the spore is present, and B, that it's the optimum conditions for the spore to sporulate. The spore trap will be really useful to us because we're able to combine it with the knowledge of the crop we have already, for example the variety, the drilling date and the weather conditions. It's just another piece of information to add to the jigsaw when we're making our decisions around fungicides, and it means that we can be more confident that we're using them in the best protectant manner possible, and therefore saving them for the future from the risk of fungicide resistance.